I guess we're gonna start doing our thing here. Hopefully everybody is on, and should somebody remind me to do the same thing. I want to get we don't usually do commercials, but this commercial happens to be about training. So if you want to zoom this in real fast, okay, last minute. We just did a 2-day AC class over here. When was it, Doreen? A week ago or whatever, a couple of weeks ago? And it was very, very successful. We had some guys, one of the guys drove in from Illinois, and guys from all over the state over here. So we're doing another one, if you saw that, on June 10th and 11th, and we're gonna do it over here. The registration link is not up yet. It will be up on, Doreen says hopefully by tomorrow, and all you got to do is, again, you go to the Dorman Training Center website, and the registration link will get posted over there. Okay, you may wish to seat if need be. Hey, how old do you think I am, Oughta Ben? No, I'll stay. Just kidding. I'll keep it going and stuff. Today, I wanted to change up a little bit. I wanted to do a little bit of meter usage. G and I both, we train electrical classes, and my electrical class does concentrate on using a digital volt ohm meter, digital multimeter, whatever you're comfortable in describing it. And experience has, both G and I, what we experience all the time is that he's got everybody that comes in, and this is why they come to classes, by the way. This is not a put down or everything. I mean, this is what it's all about. But we wind up having that, I do a lot of circuits, hands-on stuff for 2 days, and, go through all the series circuits, parallel circuits. Everybody's got built circuits. But we find in the process that a lot of guys have blown fuses, and they don't realize it until they start building the circuits. And it's one of those areas that maybe they try and mess around with the leads and everything, or try to do this, and unbeknownst to them, they blew a fuse. Well, all of a sudden, what's going to happen is when you actually decide to do, like, for example, amp reading, and you get nothing on that screen, and you're over there like, oh, there must be something wrong with the circuit. Well, is it? How about your meter? And those are the things I want to cover. Plus, the slide portion is going to be a little short. I'm not going to have that many slides. We'll talk a little bit on meters and stuff. But I did set up. If you want to pan around here a little bit, just if you showed on the table different meters, and if you see this board over here, you can zoom up over here. I'm going to shoot off the seat of my pants, and we'll see what kind of trouble we're going to get into, because I'm one of those firm believers that touchy-feely, there's nothing wrong with that. So given with that, let's go right into the slide presentation here. We'll open it up, and we'll see what kind of trouble we're going to get into. And of course, that's me. Don't even hang in there. You got it on the handout, And what we're going to do is we'll cover various digital multimeters that are available out there. Get into some meter description. Definitely I want to get into proper meter hookups in various circuits. And, like I said, we're going to do some live demonstrations and stuff. So, meters, to tell you the truth, they're nothing new. I mean, again, I'm not going to allude to how old I am, but I'm thinking of some of these meters were way before my time even, okay? But basically, we're not the first generation to use them, I mean, electricity has been around forever and ever and ever, And again, the one that you see over there, I thought it was a neat idea here. How about this? A little bit of a pocket voltmeter, Keep it in your pocket and everything. How neat, huh? How about this one over here, okay? That meter actually has a hanger. If you want amps, you hit the amps over there, so you can flip-flop back and forth. But like I said, meters, all sorts have been out there. But today, to be honest with you, And you're going to see a bunch of different meters here. Okay. I got a variety, all sorts. I play around with meters. I still like, don't get me wrong, I like my old flukes, but when we do the classes, we have everybody coming in with all sorts of different meters. They could be on the pricey end, they could be on the cheaper end, and it really doesn't matter, you know. Some of them are kind of like you pay what you get for, and you know, like I said, for example, these over here, they're probably around the $30, $40, $50 range, you know. This one I just acquired. I haven't really played with it. It's we'll see. I might turn that on, and of course, good old fluke, you know. And here's the Nurian that I actually have it on that iPad, and you use that for a hookup. That seems to be pretty good. You can flip-flop back and forth, and reading-wise, it's great. You load down the app, you can put it on your phone or whatever. And, of course, you got the flukes and, you know. But I got all sorts of them, you know. So, like I said, I'm going to keep it loosey-goosey today a little bit. And I call them, you know, they're part of an array of what we call electrical service tools. Scan tools are there, lab scopes, they're all part of it. And so are these. Now the flukes, I just want to mention this, you expect to pay more for these, but they are durable and simple to use. You know, I've had my fluke, probably it's as old as I am, just kidding, but I mean, it's been tossed around, flipped around, and you know, I mean, it's been through everything, rain, snow, you name it, you know. But if you do purchase or own these, you owe it to yourself to use all the features of these meters, everything that they can offer. And I think sometimes that's what's lacking out there. You spend good money on these meters, and are you really using it to your full potential? So maybe we'll play around a little with these, see what we got. These are the meters, they're the cheaper monetary-wise, and I threw that in for a reason. I said monetary-wise. However, they do offer similar capabilities, reading electrical properties, okay? The one where I have with the arrows takes a little bit of an understanding and learning curve, you know, because you have to actually manually range those in different areas. And again, if you're a technician and this is all you can afford, boy, I got to tell you, go for it. I sincerely mean it. Go for it. Whatever your pocket can afford, get a meter and start using it. It doesn't have to be the latest, greatest with all the whistles and bells, you know. So then, of course, not to mention, along with those meters, you can see an array of them over there, inductive type, okay? There are inductive type that are standalone types, okay? I'll try to hone in on them. For example, this is a standalone, okay? This is standalone, this is standalone. However, these two over here, you couple them into your digital multimeter, voltmeter, whatever you're comfortable with, okay? But they're very, very handy. Inductive, meaning that you don't have to break into a circuit, in which I'm going to concentrate more on breaking into a circuit. You know, I got a few circuits I set up over here just to get comfortable with. Okay. So example of inductive clamps used with a meter to read, let me get that little picture out of there. Used with a meter to read amps, you know, and I am kind of emphasize a little bit more on amps, because there's nothing like looking at a circuit dynamically working. You know, you can get a lot looking at amp readings. There's such a relationship between volts, resistance, and amps. And boy, if you understand volts and resistance and you can do a little math, you know what your expectations are for that amp reading. Because amps is power. Amps is what really is going to do the work in any circuit. But let's get back to this. You know, these are clamp-on accessories used as clamp-on meter for measuring AC current. Clamp is wrapped around a wire carrying AC current, then transformed to an AC voltage, so that the meter uses the volts function to measure the AC current in the conductor. So basically, there's your description, what happens internally. And I'm not concerned on, you know, what happens. Basically, most meters for years and years, they're basically voltmeter, but everything gets switched over, you know, internally shunted and so on for amps. And you know, these clamps will connect to and work on most meters regardless of the manufacturing price. So again, If you want to have a time saver, you know, get yourself some inductive clamp type of meters, you know. So the electric service tools today, the basis of any electrical diagnosis is accurate information. That's why you want these tools. And the reason we want them is because we can see, the electrons flowing through an electrical circuit. Fortunately, we can see its reaction, such as light, you know, the balls, motors turning, and so on. Right? But that's all we know, you know, possibly bright or dim, or the speed is up on there, whatever the case may be. Eh? If we suspect an issue with the light, and I'll stick with stupidly simple bulb, we need to determine how much and what direction current is flowing, or the resistance to that current flow. So we need a lot of more information than that test light of ours, you know, will give us. So to look inside a circuit and interpret its function will require the use of electrical service tools such as the meters that we're going to discuss today or play with, you know. But again, I alluded to that, I showed you quite a few. You know, you got expensive meters, you got cheaper monetary wise, and so on. And most of the times, everybody will ask the question is like, you know, I want to look and buy a tool, you know, so what do I do? What am I looking for? And by the way, this is where the electrical classes wind up being nice, because I limit to 10 people, but everybody's going to come in with different meters, and the guys will look at everybody's meters. Oh man, yours is working good. Oh, mine is floating all over the place. Oh, what kind do you have? How much did you pay for this and everything? Wow, this is great. Whoa, mine isn't too bad either, you know. And a lot of guys, might be their first time and they don't have to bring a meter, but that might help them make a decision on which meter to buy. But anyway, important things to consider: accuracy all day long. I mean, we're trying to measure millivolts, milliamps, and you know, we got to be very accurate. You know, dependability should be one of the determining factors. Right? You don't want to go in a wrong direction in your diagnosis because of an inaccurate reading. Right? And I gotta tell you, I hang my hat on this next one, this next factor. What do I want to know? Okay? And that requires having knowledge of the approximate range of voltage, amperage, and the resistance at which the circuit normally operates. Note, and I put a little note in for it, this information is necessary to prevent damaging either the test equipment, your meter, okay, or the circuit by overloading when the test equipment is connected. You know, you don't want a voltmeter used to test computer circuit will require at least 10 meg ohms to prevent circuit damage, okay? And that's why we got away from, I'll just flip over the camera. You can stay there, you know, I'll flip over. That's why we got along, and you can zoom in, we got away from these analog type of old meters. They had a lot of issues. Maybe I'll play with it a little bit more, but there were some parallax issues, and they were polarity sensitive, so if you hooked them up wrong, for example, I'm going to drop the leads here so I can, if you hooked them up wrong, that needle will go boom, flip right over, hit the peg, and once it bends, it's like, do you have an accurate meter anymore? And if you look at that dial over there, my gosh, they got everything on it, and try to read those. You're looking at numbers, you know what? It's akin to an old clock. You can back up. It's akin to an old clock, you know, with the handles. Yeah, back up quite a bit. Thank you. You know, where the hands go like that. I actually ran across a few guys that they'll look up at the clock, honest to God, okay, and they can't read it. How do I know? Because they used to come over at the workstation where my son is with the computer, and they'd look on the computer to look at digital hours, you know, to mark their worksheets with it. And it took us a long time to figure out, this guy, he can't read a clock. He's got to read, you know, the numbers elude him. He's got to look at the computer on the bottom. You know what I'm talking about, where you have the hours on there. So, you know, it's a strange world we live in. So let me get back on this again. So we'll move on. Of course, the most common tool used for isolating problems in an electrical circuit is a digital multimeter, you know. And I'm not going to hang my hat on who wants to call it whatever, also commonly referred to as a DVOM, digital ohm meter. Meters are used to measure three very distinct properties of electricity: voltage, electrical pressure, going to measure that by your voltmeter portion of it; amperage, that's the flow, current, measured by an ammeter, electrons going through the circuit, you're actually counting electrons; and of course we're always going to wind up having a resistance to that amperage flow, commonly called resistance in ohm, measured by an ohm meter. Now, the nice thing about these digital multimeters is they combine all these functions, plus more, of course, into a single, convenient, simple unit. It's there, right? Touch it, move the dial, hit the right pockets and everything, and you're good to go. And when I get to pockets, I always emphasize the pockets, and I'll show you why. Now, following is an example of having knowledge of approximate range of voltage amperage. Why don't we use an ohm meter to locate resistance in the ground or return side of a starter circuit? Okay, keep in mind the starter circuit is a high amperage circuit. I just put round typical, typical amperage load of 400 or more amps. I used a 400 to do it, just a stupidly simple math here. So using the 12 volts and 400 amps, if we do the following, 12 volts divided by 400, you're going to come up, if you use your calculator, I gave you the answer, say thank you, 0.03 ohms. My question is your meter capable of measuring accurately to 1/100th of an ohm? This limits their application of electrical circuits designed for current capacity of approximately 20 or so amps. So what are your options for locating resistance? All day long, you hear voltage drop, voltage drop, voltage drop, voltage drop. You cannot beat a voltage drop test, okay? Now, the digital meter advantages. They're easy to read, absolutely. Best for finding precise value of voltage, current, or resistance. Readout is accurate to 4 places in most cases. So here's an example, 12.25 volts or 0.654 amps. And of course you can manipulate doing that with your manual range, or if you got auto range, it'll pick all that stuff up. The other good thing, and we already mentioned, is a digital volt ohm meter has a very high internal resistance, up to 10 meg ohms. With a 10 meg ohm resistance, the internal amperage is very small. Take my word, very, very small. So if you connect it into a computer circuit, for example, it does not add any load to the circuit. And that makes it ideal for use in very low amperage computer circuits. And I'll be very honest with you, we've evolved to the point that I'm not quite sure if I keep buying some of these meters just to see how they work and everything. I don't even bother looking. It's kind of a given they're all going to be like 10 meg ohm. Nothing you have to search for anymore. Digital meter advantages: meter protection. Meter protection circuits, and those are internal, prevent damage to the digital volt ohm meter. Specification of input protection indicates the amount of voltage, something you don't see again, overload, which may be applied to any function or range without damage. I mean, they take my word for it, they're very, very durable. Current measuring, you've heard me say current, amps so many times already, okay? The current measuring circuitry is typically protected by fast blowing fuse in series with the input leads. I already mentioned auto ranging, automatically adjust the meter's measuring circuits to the correct voltage, current, or resistance ranges. Typically, I just happened to look over, Harley just put something, and you gotta forgive me, I get so into it, so if I glance over, I might catch something. Make sure you read the screen correct. You might want to expect volts, but it's actually millivolts, and that will lead you astray. Very good, Harley. Right, we're gonna do that. We'll show the differences moving, good reminder. Thanks, Harley. Auto ranging, automatically adjust meters measuring. Typically the digital volt ohm meter starts on the lowest range you know, and then automatically moves to the next higher range when auto range takes place, you know. And of course, manual range, and Harley's talking about that, overrides auto range to allow for measurements within a specific range. And with that, you know, that said, with the manual range, absolutely, you watch the decimal points move, and you really get a more precise, because actually, you take so many circuits, I mean, you know, they're into plus minus this, you know, plus minus in milliamps, plus minus in resistances, and so on and so on. I mean, look at the fuel injectors. I mean, you want the resistances low. And I'll do something real fast. Let me switch over to this, because in case I forget to do it, but electrically speaking, I'm gonna put my thing down. Electrically speaking, I'm resistances, okay? So if this was my resistance here, okay? If resistance is high, this is current, by the way. Resistance is high, current gets low. If resistance is low, current goes up. That's the biggest relationship you're gonna wanna walk away with, okay? The resistances are so important. So just a minor resistances, you know, even in the context in a relay, I've had relays shut down a vehicle because there was enough of a resistance in the context. But anyway, you know, that's what we try to do with the electrical classes. So meter protection, and this is a perfect example. Testing 15 amp 600 volt fuse. So for example, with a flute, and you need to read your own meters, okay? So if you happen to have a flute, set the rotary switch to ohms, plug a test lead into the volts ohm input terminal, touch the probe to the A input terminal. Don't forget, this has a split context. Be sure you touch the probe to the upper half. And you should come up with a reading between 0.0 and 0.5 ohms, okay? And of course, OL overload, guess what? Get a fuse. The fuses in your flukes tend to be very pricey, just so you know. Then you can do the same thing with your 1 amp side over there, insert the lead, and so on and so on. But the point being is that, you know, you don't have to necessarily take the back of the meter out and do a resistance check over there, you know. Is it open, using your ohms, you know, try to see if you got an open fuse or not. You know, you can do it right face up front, okay? And again, in this particular case, if you're going to use your amp meter portion of it, you really do want to make sure. You don't want to go down a rabbit hole thinking there is a circuit issue, when in reality, again, I mentioned that the issue could be your meter. Okay? More advantages, auto polarity. Oh, that's a nice thing. I mentioned that with that analog meter. Boy, you reverse the polarities, boom, that needle's gonna peg over, and it's like, oh boy, from that point on, do you have an accurate meter? These meters over here, doesn't matter. If you happen to cross over, you're still going to get the same reading. You're just going to have a negative in front of it indicating, you know, the polarity, you know, and basically you just reverse the leads or whatever, or, you know, if you don't want to reverse the leads, the numbers are the same, you know, so. Many digital multimeters have a hold feature operated by means of a special hold button. You know, there's quite a few different makes have that. That's useful when making measurement in a difficult area, okay, allowing the readings to be captured, held, read when convenient. And you know, guys, we're contortionists. Sometimes you got to get underneath there, and you're doing whatever, and you really can't see the meter. Your head is turned this way. You're trying to hook up the leads to someplace else. It's like, you know, I often say most mechanics, they really should be gymnasts, you know, but you can just hit that whole button, and then if you can read it again, you know, get your head up, you can look at it. So there's a lot of conveniences with this stuff. Semiconductor testing, okay? All the meters that I showed you, whether it be the monetary cheapwise or whatever, they do have a diode or a semiconductor check function. Basically, that function has an ohm meter over voltage of greater than 1.5 volts. Thus, continuity for most diodes and transistors in forward bias direction may be checked. And I'm going to try. I got some diodes over here. We'll look at the difference between that. So, a lot of the stuff you're seeing here, we're gonna actually try to put it on. I'm one of those hands-on guys. I love doing hands-on stuff. But regardless of low resistance, both directions indicated shorted diode, high resistance, both directions indicated open. Causes high current has destroyed internal connections or high voltage broken down the chunks. And you might ask yourself, I'm going to give you a little bit of reminder about, I'm going to give you a little reminder with that AC course. We were talking about that. If you got climate control, you might have some, you might have a diode in that circuit, because what happens is, say for example, you build up your clutch in your AC, right? You're kind of current ramping, it's going to go up, you're going to turn it into electromagnet, you know, and it just like ignition coils, you know, between a primary and secondary, you shut that off, you're going to get some huge spikes of voltages going up. Well, in today's climate control, you know, you got all that transistors and everything in there. If you let those spikes reach those modules and stuff, you could blow something. So we highly recommend, you know, if you do get in a situation, we got a blown, you know, climate control switch module or whatever the case may be, try to see if there's a diode in there someplace, you know. And don't put it back together until you check that diode. And I'm only giving you an example because often a lot of guys ask, well, I never run across a diode. You never know when you might run across a diode. Okay? So kind of keep that in mind. You know, and I'll be honest with you, seems to me this is the most commonly used test out there. This is what most guys use their meters for, okay? Open circuit voltage test allows battery state of charge to be determined using, you know, and again, a little reminder, if you do that, remove the surface charge first to obtain an accurate reading, you know. And here's just an example. Turn off if you wanted to get rid of the surface charge, you know, if you have those conductive testers that a lot of you, some of you might have, you'll notice when you go through that in your battery starter alternator check, you know, it might tell you to, you know, hey, turn on the headlights and stuff and everything else. But what it's asking you to do is remove the surface charge, so even with the conductance tester you get a good valid reading, you know. So, but a good reading would be 12.6. And again, everybody calls it a little bit something else, you know. I say it's a steady state or no low battery voltage reading used to determine the state of charge, you know. So, and again, 12.6, and it doesn't take, you start dropping down to like 12.4, 12.5, believe it or not, you're dropping down to about almost, you know, again, I'm pretty sure it's pretty close to like 75% charge, you know. So to tell you the truth, this is where you do want an accurate meter if this is what you're going to use your meter for. Now, you might not hear it too well because I don't know if you can hear it there, but I'll walk you through. Here's a perfect example, you know, just walking around with your meter, and this wound up being a no start. And you see, starting at the battery poles, the main cable, you know, we had plenty of voltage, available voltage. You see it over there, but one of the cables down there, right there, nothing. And this was going to, you know, get the vehicle started, and it just wasn't there. Vehicle couldn't start. So there's a perfect, most simple use of your voltmeter. Here's another example. I'm asking a question. How many volts do you see? Hey, it's pretty bright, right? I'll keep asking. How many volts are you seeing here? How many volts are you seeing? Oh, it's a little bit dimmer there. I grant you. See, it's dimmer. But you tell me how many volts. How many volts am I dropping here? So the test light does have its uses, okay? The test light does have its uses, but I got to tell you in all honesty, get used to using your meter. Much more information you're going to receive from there. Okay? Now, this is Know Your Meter. You know, RTFI, you need to go into your manuals, okay? So you need to get comfortable with where are you at. You know, what's this? Volts AC, okay? Digital, volts, okay? Your higher voltages. Oh, there's my millivolts. Over here is my ohms, okay? Here is my diode setting over here. Whoops, let me back up. I lost it with that. But you have a lot. Everybody's got a little bit of different things. And I'll show a meter, because some will have the mini max and so on and so on. But right now, the biggest thing, whenever I do this in class, I got to make sure everybody knows. See these pockets here? When you play with circuits, somehow you have to embed it in your mind. No matter what you do here, if you're going to move over to amps, you better pull your red lead out of here and you put it into your amps over here. And your amps, you have two pockets over here. It's the same thing like you got volts and millivolts, but you better need to know how much amperage is in that circuit, because this is 10 amps. Usually that's about 1 amp. And boy, if you get it wrong, you'll blow a fuse. And we'll walk through that a little bit. So please, that is, you know, and we have a hard time, okay, doing that mindset. It's almost like muscle memory. The only way you're going to do that, you start really utilizing your meter. Measuring voltage drop. This is a parallel connection. Meter is placed across the load. The number of volts measured will be available voltage or voltage consumed by a load. And that's what you're doing. That's about your most popular hookup that you're going to wind up having over here. You know, measuring current. This is the one I said you switch the pockets, okay? Know the anticipated amp reading. Okay, your meter has limits again. Okay? What you're basically doing here is you're breaking into the circuit. Your meter actually becomes part of the circuit. Okay? And I always say, you know what? This meter becomes an electron counter. You always have to break into the circuit if you're going to do that, unless you have an inductive clamp that you're going to use. Okay? And of course, resistance, same thing. Very important. The circuit component has to be disconnected from its power source. The meter supplies a component with a known amount of current. Okay? And the meter is going to calculate the resistance component. Make sure you have a good internal battery. Now, let me back up on all these three things. If you guys are like me, most of the time I'm over there using my voltage and stuff. On occasion, I might use my resistance, okay? And then all of a sudden, dummy me, I'm going to take an amp reading and it's muscle memory. Oh shit, excuse my French. I forgot to switch over the pockets. That happens to the best of us. And this is why the only way you can get your mindset is actually play around with that meter. You know, if you got some spare time, as if, yeah, anybody has spare time, right? But, you know, instead of taking your test light, grab for that meter, okay? And again, we can spend a lot of time with voltage drops. You see this one over here. We're looking at available voltage and so on. And you can and you have your handout. Stop and think of what you're actually doing. Here's my battery, okay? You know, we followed that circuit, okay? But then again, here's an example of doing you determine initially that in my power circuit, I have a voltage drop. So now you're going to try to do some pinpointing. And this is a butt connector. Do we even need to get into a conversation about that? But don't forget, those electrons, when they leave, okay, when they leave the battery, they're going to go through the load, and every one of those electrons are going to go right back to the source, which is your battery. So you can also take a voltage drop reading on the negative side, okay? Because that's all part of it. You know, if you got a resistance over here anywhere, that's going to affect what's going to happen over here. So, you know, sometimes we got to get creative, okay? This is a this is, again, it's hard to hear, but again, this was, I believe, I can't remember, I think it was an Isuzu or something, checking the wheel speed sensors, and it's got a Hall effect type of wheel speed sensor. So if you didn't know that kind of stuff and you're looking for AC voltage on this, spinning the wheel and everything, or you're actually even looking just for resistance, you know, and I don't care whose resistance it is. Usually if it's the AC type, you know, when it's just sitting there, you're looking at your sensor, you're going to average, and again, 700 to 3,000 ohms, depending on whose sensor it is. But this one here, I had to rig up because, guess what? I need to see what's happening with the wheel spinning, and it was 0.65 to whatever I had over there. But again, that meant I had to put some couple resistors together. I miss Radio Shack. I used to be able to do all that stuff. So yeah, 3.9, it wound up to 3.65. But it's a wheel spin, because if I didn't do that, it could definitely lead me in the wrong direction. What if I determined there was a computer issue $2,500 later when it's, hello, you know, it's a circuit issue. So testing for terminating resistors. Okay, I mean, so far we've been talking about the little stuff. How about a missing terminating resistor? It's going to result in high resistance. What happens if an additional terminating resistor is added? Somebody added something to this circuit, you know, and this can occur due to an installation of an aftermarket controller or the bus, excuse me, not the bus we drive, electrical bus, and that controller has an integral resistor. Easiest way, of course, to test for the above issues, use your multimeter in ohms. Make sure that bus is powered down, ignition off, and both terminating resistors are in place. Okay? Then you have it in your handout, you know, just get in there. I'm thinking, I don't know if it was my OD classes or whatever, you got pretty near the same slides on there. So again, you know, what I'm going to do is, this is as far as I'm going to go, because I have a little bit of time. I want to just do a little bit more live stuff. I want to do hands-on, and I'll be honest with you. I'll be honest with you. I'm gonna shoot off my hip this morning. I gathered some stuff, put a bunch of stuff here. Might not be perfect when I get done with it, but hopefully, you know, kind of chill out type of let's see what we can do, you know. So let me walk over here, and hopefully my granddaughter. Oh, here, Lena, come over here. Just once, 2 seconds. So when I'm hollering, she doesn't mind. Stand there. This is my granddaughter. She's shy. She's doing the camera work, and she's got the O&K. She's actually working on the floor. And if she walks this way, that's Elena. Okay? Thank you. Can't do it without her. So, okay? But anyway, if you hone in over here, let's see what kind of trouble we can get into. Right off the bat, let's do this. I'm going to fire this up over here. And too many leads all over the place. Let me find them. So again, one of the easiest tests that you can do, and you want to be accurate with your meter. So can you hone in? Yeah, that looks pretty good. I'm going to connect these two leads together, and what I'm going to do is I'm going to hit the 0 button. Okay? And basically, let me get it on ohms here. Excuse me. I'm going to connect the leads in. Okay? And over here I got 0.3 ohms. The nice thing about my meter over here, if I hit the 0 button, okay, the best way of explaining it, it kind of forgave me, you know. And 0.3 really isn't nothing, to tell you the truth. But however, you know, if you're getting into a circuit, say I got 1 ohm resistance here, and then somebody tells you to, gee, you got a plus or minus 1 ohm on a very low resistance type of a circuit, it really can lead you a wrong direction because you didn't deduct that. But here we have volts, okay? And most of your leads, most of the time, this is what we're using it here. I'm just gonna put it on real fast over here, okay? And you see 12.6. And again, let me switch it around. Does it really matter? You know, I lost a point, you know, very small, but it doesn't matter. Nothing got hurt, okay? However, if I use my analog meter over there, I'd have some issues. But we have a variety of different meters here. So sometimes it's like we had 12 point whatever I had over here. Let me find the leads for this. So sometimes I want to look at the accuracy of some of the meters, different meters. It's kind of nice thing to do. So we had 12.6, and this is a cheaper meter. Okay? So we're pretty close, 12.9. That's not bad at all. Okay, and even some of these meters over here. Okay, now I will hone in on this one a little bit. Okay, this is a lot of guys come into class with this one here, and there's nothing wrong with it. You know, this is your cheaper one. But if you notice over here, okay, you got to range your volts. You know, you're playing with 20 volts, 200 volts. Okay, and of course the other thing right here, 20 million ohms. Okay, and I can't see 200,000, you know, 2,000, and it goes on and on 2,000, you know, and it goes on down to 200. So when you're playing around with that one, you kind of have to know what you're doing, okay? And I'll show you, actually I'll show you that in a second. But anyway, comparing, you know, my voltages here. So I know I'm going to be with, you know, for chicks and giggles, let me which leads are these. So if I'm on the wrong range with the volts here, this is my not too expensive one, and I'll put it into 1,000 volts, and you see how many, whoops, pull these things off of here. So you can see, man, I'm having a hard time reading this, right? So I'll bring it down to the next scale. My decimal point moved. It's not too bad, 12.4. So I'm getting a good reading over here and then over here, you know. But again, you want to range this down. And you can see now all of a sudden I got actually 4 digits, 12.59. So we're pretty close with this meter here. The same thing happens with a resistance in this particular guy over here. And I'm going to try to put this over here. Can you still see it? Pretty good. Okay, so I'm gonna put a resistance in here, and I'm gonna go like this, 0. So you might misconstrue this. Oh my gosh, this is open, nothing is happening here. These particular, don't walk away. You need the same thing. You need to bring it down, and I'm not going to do every one, but you bring your range down, and in this particular case, I'm in the 200 ohms. But my point being, on these type of meters, see that? It's not bad. 5.7 ohms through this bulb. So again, some of these meters you have to be kind of careful with. Okay? So I'm going to shut this off because I always forget to shut this off. So let me shut this off. You know, we're doing good time-wise. I'm going to do a bunch of stuff here. You know? Oh, actually, you know what? Let me do this. I'll use this one here. So I told you about the diode. I got a bunch of diodes here, so I'm going to just pick a diode. Now, I'm going to get my leads over here. Okay. We'll start a little slow. Like I said, I'm shooting off the hip here. Now I have it on ohms. And if you notice over here, I'm going to hook up this diode. Okay? I'm OL. See the way I got this hooked up? Diode is a one-way check valve. So I want to make sure it's working. Right now it looks like it's working as a one-way check valve. Now I'm going to flip this around. Okay? Now I'm on ohms. Okay. And 1.28, 1.29 million ohms. What the hell is going on here? Okay. However, now I'm going to switch this over to my diode setting. There we go. I have 0.497 and I'm in a volts DC. Okay. I'm going to flip it around. Okay. OL. I needed the voltage to bias to turn my diode on. And this is why we have that diode setting. So now, what the hell can I do here? Yeah, I do a lot of stuff. You know what? I am gonna turn on this circuit over here. How about that? My circuit is on. Can you guys see that? Just to make sure, you'll see this bulb came on. So everybody see that? It came on? Okay. Anybody, I want you to think about this. I want you to think about this bulb isn't on. I want you to think about this, guys, okay? What type of circuit is this? I'm going from, this is my top bus, my plus. I'm going through the switch made up over here, turn it on, off switch, okay? Going through a fuse, because we always blow fuse when we play around with these things. Now, it's coming out of here. It's going through the bulb, coming back out, going to this bulb, and going back out. I want you to think about this. I want you to think about this light before somebody says, hey, there's something wrong. Somebody's going to say, hey, I think you got a bad bulb. But I really don't, because if this bulb was bad, okay, probably this is where I'll screw up. If this bulb was bad, that light wouldn't come on. So just think about this. But anyway, with your meter here, and I'll use this meter here, I'm pretty comfortable with this. What you're going to wind up doing is, first of all, you know, and this might help you too. I'm going to have this off. Whoop. See, that's why I didn't want to mess with the bulb. I have it on. But if you want to mentally just try to keep these ohms resistance readings in here in mind, okay? And then you're going to start thinking about this. What do we got here? Not much of a resistance, do we? 1.2 ohms. I'm going to do this. I have, looks like 6.9 or 7 ohms. So just mark it down someplace. Maybe you'll figure out what's going on here. So I'm able to do resistance. But now I'm still in this pocket over here, okay? I'm in this bottom pockets here, if you can see, okay? Common in volts, ohms, okay? So maybe I'll do my next reading over here. I will flip this over to volts, okay? Right here. I am going to put this on ground. I'm going to put this over here, okay? I'm reading what? Battery voltage. I'm going to turn this on. Whoops, here we go again. I shouldn't have messed with this bulb, okay? You notice it dropped down to 12.64. It's a form of a voltage drop. So to be honest with you, you know, it's, in my mind, it's doing pretty good. This is not a starter motor where you're going to do a voltage drop that's crazy. But I did drop some voltage, okay? But now, the big thing is, I want to know what the current is in this circuit here. I should never have done this. Oh, I'm sorry. I'm okay. Hook back up there. All right. So anyway, I had a voltage drop. Where I was heading, I'm thinking ahead of the game, is I want to now look at amps. And this, guys and gals, is very important. You take this pocket out. You take this lead out. You have to put it into this pocket here, okay? And this is going beep, beep, beep. It's telling me, guess what, stupid? You move your dial also, okay? Now, for me to take that current reading, okay, I have to break into the circuit. So I break in, okay? I'll put this lead over here. And hopefully I don't have a blown fuse. I know I won't have a blown fuse because when I turn this on, okay, I have a reading over here. Okay? And it's 2.254. I'm in outer range. I can manually range it. Okay, and I manually ranged it, and right there by doing manually 0.25 amps. Okay, doesn't matter, and I have it what shows the negative. If I didn't want to see the negative, it is no big deal. Okay, just go like this, and I go like this. Okay, makes sense? Okay. Whoops. Stupid. I'm trying to do things too fast here. Okay. There. There. Okay. And what I meant to do was now just switch my leads. It will be okay. We think. Okay. Okay. And there we are. But I didn't hurt anything. Polarity doesn't matter. Okay? So I'm going to take this off over here. Okay? I'll tell, and again, try to keep in mind, see what's going on. See if you can think about this circuit here. Now, I rigged up a LED light over here. Okay? And I am going to do this. I'm going to go like here. And I'm going to go right to the bottom. I'm bypassing my switch. I don't like doing it, but I have nothing. However, this time I'm going to switch the leads. Okay. Switch the leads. LED lights happen to be polarity sensitive. A lot of them, more modern ones aren't, but keep this in mind. Okay, they are diodes, you know, so it all depends how they're rigged up. However, this time, okay, I'm going to disconnect this. I'm still going to read my amps on this one here. Okay. This over here, we had 0.25. By the way, you know what? Let me back up 1 second here. I am going to take this off, and because I still have my meter in amps. Okay, I'm only going to go through the large bulb here. Okay, I'm going to hook up. I am breaking into the circuit. Okay, you can see I'm down here on the bottom. I will hook my other lead over here. I'm going to turn it on. Wow, I'm up to 207 amps, and this light does work, doesn't it? So keep that in mind. I'm not near the chat box, so I can't see who's saying what or whatever, but it's just food for thought. I want you to think about this stuff. So I'm going to hook this up. I'm going to put over here again, and I'm going to rehook my ground over here. But my point being is, now we're working with this LED. I still are on my amps are, yeah, learn to talk, dude. So I'm going to put I still breaking into the circuit here. I have to break into the circuit. Okay. Notice the light came on. Okay. And I am into 0.23 amps. Very, very low current, okay? I'm safe enough that I can actually flip over to, well, doesn't matter. I'm flipping it. I'm going to try to, I'm in auto range, 0231. My point, I was trying to do this. If I manually range, Harley mentioned about, you know, finding the right range, okay? And you can see the decimal points move. It's easier for me to see the 0.23 milliamps. But again, if you're working computer circuit similar, you better make sure that your meter is capable of really reading these nice little low amperages. So let's see what other kind of trouble we can get into. Oh, I know what I wanted to do. Whoops. Get it out of the pocket, you know. So I'm going to turn this off for a minute. I'm going to disconnect this. What happens is when I get in a hurry, this is when I am going to wind up having problems here. You know, I'll blow something or whatever the case may be. I'm going to put this down because I want you to see something. I just, if you went back up, I just purchased this from Power Probe. Okay, we're talking about doing amps. This one here, I turn it on. Okay. And if you can see closely over here, what I need to do is I'm on a mini fuse, and I'm going to boost up my mini fuse to be on the safe side. 3, 4, 5, 6, 7, 10. This, I hope you can see in here. I'm going to turn this on, and what you're going to see here is I'm going to put it right on the fuse. I'm trying to do it upside down here. Okay. I need to hit the contacts. Blind as a bat. 0.25 amps. Can you see? My hand is in the way. Damn it. 0.25 amps it had on there. What basically happens is, and I should have held this up a little easier so everybody can see. And then if I let go, that's the only thing I have a hard time with, you know, is trying to get a good contact. And if the fuse was staring me in the face, you know how it is, and you know, it worked. Take my word for it. Oh, right there, 2.24 amps. If you can see it, you know, again, my finger is in the way. I'm going to try to move 0.24 amps. It's a nice tool. So basically, if you back up, if my fuse was, you know how it is in a fuse box, if you're staring there, I'll have a better time of getting it in. So this is something Power Probe came up with. We got only a few minutes left. I want to move over here real fast. I want to show you again. Let me shut this off. Time flies. I had this motor here, just so you guys know. This is I'm getting ready to do a tech competition, not this weekend, next weekend. I got a bug on my brake boards. I got 2 of these I built. My son is bugging it, but I have it unbugged here. You know, fuses will get changed, this will get changed and stuff. So this again, I have my meter on here, okay? And in the real world, if I take this, switch my pocket, okay? Now this is actually on a blower motor circuit here. And then if I get this down to my amps down here, and I break into this circuit over here, and let me just get my other leads here real fast from my other fluke. I like the alligator clip ones. Take me 2 seconds. Leads are leads are leads all day long. I really do want to show this, you know, because I also want to show in a real world application. So if I break into this, my pocket, very important, switch the pocket, always switch the pocket. I'm in amps, okay? So I'm going to turn this on, and can you see the meter real pretty good? I'm going to break into this circuit. This is my blower circuit. Okay? I'm going to go in here. I'm going to turn this on. I lost connection or something. Oops. Uh-oh. Uh-oh. I have a problem. Okay. I have a problem because this did not come on. It should have came on. I had it running this morning. Sorry about that, guys. It's running. Guess what I probably blew on this thing? Eh? I probably blew my oh well. So now let me get my leads back in that I took off. And I want to verify something. Pull this off. I'll put this over here, like my alligator clips. Yeah, definitely. But I'm gonna switch my pockets again. Whoops. I know what I did wrong. Why didn't you guys catch me on this stuff? You see it move? Eh? And I can go through my speeds, move it through my speeds. Okay. You see the readings? Yep. Okay. So what did I do wrong, guys? Which lead did I not do right? And I thought you guys would catch this. Eh? Show you real fast. Get my leads on. We're almost done here. Just bear with me. Eh? And this is why I like my alligator clips. Eh? And all you guys were watching me, and you should have caught it. I had the wrong pocket here, and this was my whole point of everything that we tried to do in class, that muscle memory. And now I can go through all the speeds. Make sense? Okay. I can sit there by the dashboard, find out where my blower motor is, and I can verify. The guy says, hey, I don't seem to have a lot of good speed coming out, and instead of me trying to condemn the motor, let's make sure that we can control this real good. This time, everybody observe, this went here, and this is my common. I'm gonna hook this up over here, okay? And I'm going to shut this off, and because I got my alligator clips, I can very easily put them on over here. I'll get this out of the way over here, make sure I'm not touching. Okay, I'm going to turn this on. Whoops. And you can see my voltage is changing every time. What is happening here? Low speed, lower speed, low speed. I'm doing a voltage drop, believe it or not. It's a design voltage drop. So we're over time here. Man, I didn't even realize I could spend forever and ever doing this. I really enjoy doing this. So I'm gonna move this forward. If there's any questions, you know, try to ask him, you know, we'll try to answer them. If I don't have it here, G said fluke brand on leads. Yeah, absolutely. Good stuff. So I don't forget, I want to leave that slide on here. But while that slide is on, guys, okay, while that slide is on, please hit that QR codes if you can, whatever. Send us a little bit of a feedback. Does this work for you? Doesn't? And whatever else. And one last thing I'm going to switch back to me is here. Keep this in mind, okay? AC class, June 10th through 11th. I'd love to see some of you guys come over here and meet you in person, and so would she. We have a really good time over there. And by the way, the lunch we provide every day is really the greatest in the world, you know. I mean, you'll never have better pizza than stuff from Buffalo area and wings and everything. So, but again, thank you guys. Thank you for participating, and again, and we're going to have to wrap this off.